In this section, we're going to learn a few things. We're going to learn how to analyze rational functions. We're going to learn how to graph rational functions as well. And to even begin to do that, first we have to understand what a rational function is. Right, so far we have had what we call polynomial functions, which look like this, right? F of x or k of x is equal to, a polynomial function. We talked about what that was. Now, imagine if you take a polynomial function divided by another polynomial function. So, for example, imagine if I said f of x is equal to x squared plus 2x plus 1. That's a polynomial function. Divided by x minus 4. That's a second polynomial function. Together, this is a rational function. Okay? So the way it's defined is, we say, because it's two polynomial functions divided by each other, we say a rational function is the quotient of two polynomial functions. Okay, now, so if you have a function in the numerator and a function in the denominator, you're again going to run into this problem of possibly the denominator being 0, right? So that's what we have to watch out for. That means, what is the domain of rational functions? The domain is all of the numbers except the ones where the denominator is 0. Okay? So it's all numbers except the ones for which the denominator is 0. So for this one up here, for what value of x is the denominator going to equal 0? 4. So the domain is all numbers except for x equals 4. Okay. Another thing about rational functions is many have asymptotes, right? So let's talk about what type of asymptotes they are allowed to have. Rational functions can have both vertical and horizontal asymptotes. Okay, one is independent of the other, right? So we're going to treat them independently. Okay, what does a vertical asymptote look like? That's a vertical asymptote. That is a line that the graph absolutely cannot cross. Okay? Graph cannot cross that line. Like, it can't cross that line. Okay? All right. How do we find vertical asymptotes? It's actually rather straightforward. To find vertical asymptotes, first you simplify the function. That's super important. Like, I don't know how many stars to put next to that one. Okay? Then find the zeros of the denominator. Okay, now I need to put a little caveat, a little disclaimer here. We're going to run into this later. These are the zeros of the factors which cannot be eliminated. Okay, which means, suppose you have, you simplify a function and you have, f of x is equal to x plus 2 over x plus 2, x minus 3. Right? Can anything in the denominator cancel here?
Yeah.
The x plus 2's cancel, right? You cancel them. Did the x minus 3 cancel? No. This is a factor which cannot be eliminated. That's what you set equal to 0, and that's the vertical asymptote. So now you say x minus 3 is equal to 0. X equals 3 is the vertical asymptote. Okay? So that's important. And that's all you have to do for vertical asymptote. Look in the denominator. See if anything cancels. If it doesn't cancel, vertical asymptote. Okay. There can be multiple. Okay. Horizontal asymptotes look like this. Okay. We said a vertical asymptote is a line that the graph cannot cross. It's like a wall. Can't cross it. Now, here's what a horizontal asymptote looks like. And so here's the deal with horizontal asymptotes, though. I can have a horizontal asymptote here, like this. But it's very, okay, so horizontal asymptotes only take effect at the very ends. So at the very end of this, the graph will level off according to the horizontal asymptote. But it is possible for the graph to come up and then down and cross the asymptote. And then it's possible to cross again and again and again and again and again, and then follow the asymptote at the end. Okay? So that's the deal with horizontal asymptotes. They only take effect at the infinities, at the very, very ends. A graph can cross the horizontal asymptote 1,000,001 times, and that's okay. Okay? All right. This is a point often that, many people miss for some reason, but I always want to clarify it because it'll, if not, you might run into trouble later. Okay, how do we find horizontal asymptotes? There are 3 cases. Okay. What you have to do is this. You have to look at your function, and you have to go and you have to look at the term with the highest exponent. Okay, so what you do is this. You have to divide the term with the highest degree in the numerator by the term with the highest degree in the denominator. So here are the 3 cases. Number 1, if the numerator has a lower degree, right? If the numerator has a lower degree, the horizontal asymptote is y equals 0. So look at this one. I have this, complicated function. I go in the numerator. I look at the term with the highest exponent. That's this one. Okay, what's the exponent there? 2. And then I go in the denominator, compare the exponent. What's the exponent there? 3. Okay, so lower on top, immediately I say, you guys know what those 3 dots mean? Like that? That means therefore. That means therefore. Oh, nice. So that's a mathematical symbol. That means therefore. It's just 3 dots arranged in a triangle. It's like, Okay, so therefore, the horizontal asymptote is y equals 0. That's it. This is the simplest case. If the denominator has a higher exponent, right? Y equals 0. It doesn't matter if it's higher in the bottom by 1, by 2, by 7, by 11. It really doesn't matter. More exponents in the denominator, y equals 0. That's it. Always. Doesn't matter if it's positive or negative. Doesn't matter if you're in France or in, I don't know, the southern hemisphere. It doesn't matter. It's all the same. That's case number 1. Case number 2, what if the exponents are the same? What if you have equal exponents? What if the numerator and the denominator have the same degree? Then the horizontal asymptote is the simplified fraction. So you look here, negative 5x cubed, 2x cubed. What's the horizontal asymptote?
3.
Not 3. You simplify them. You say y equals negative 5x cubed over 2x cubed. Basically, it's negative 5 over 2. So y equals negative 5 over 2.
You completely disregard everything.
Everything is disregarded. If you want, you don't even have to take the x cubed. You can just take the coefficients. Okay? So you can take coefficients only. And you can just say y equals -5/2 from the very beginning. All right, so that's if they have the same degree. Okay, so we did the case where numerator has lower degree, same degree. The next is, what if the numerator has a higher degree? Then there is no horizontal asymptote. Maybe that's the simplest case of all, right? So if it's like x cubed over x squared, no horizontal asymptote. All right? Okay. So here, we want to find the domain, vertical asymptote, horizontal asymptote.
So
Yep.
for the equations on like Trig or wherever, you always ask me the vertical, we need to find like vertical plane or something. Like you want to ask or just give us for example.
I might.
Oh,
Yeah, if I, yeah. They're completely independent of each
you
other.
don't have to do all three.
No. You just give me what I ask for. It's like if I were to ask you for your address, you don't automatically give me your phone number with it, right?
Yeah.
They're different things. It's the same, yeah. Okay. So, for the domain, I need to look at the denominator. Set denominator equal to 0. Okay, so the denominator is x squared minus 1. I need to set it equal to 0, right? You can solve this in multiple ways. You could add 1, take a square root. You could factor. Either. Why don't we add 1 this time? X equals, oh, sorry, I need to take a square root first. So x equals plus or minus 1. Okay, what does that mean? That means these are the points where the denominator equals 0. So the domain is the reverse. It's all numbers except plus or minus 1. How do we write that? Okay, you guys know this. Okay, so the domain is, do you guys know this symbol? All reals? First, I'm looking for the domain. They're similar. They're very similar. Okay, so you guys know that means all real numbers. Minus, okay? I'm just saying that the domain is all real numbers minus 1 and -1. Yeah, it's the curly brackets. Sorry, guys. That's set notation. Okay? You have to write it like that. You do have to write it like that. You can also say, you know, all real numbers, it's the same, but like you can also say all real numbers minus plus or minus 1, but it, you know, we need that curly bracket. Because if you do square brackets, not the same thing. Parentheses, not the same thing. It might not be a big thing to you, but it's a big thing to, like, you know, math people everywhere. Yeah.
Why did you write it R minus 1?
That's what I'm saying here. Is you can also write both. You can also write that one.
Both
Both
are acceptable.
are acceptable. Yep. I did this way now. I might not do it like this again. I just did it right now to stress that it's two distinct points, 1 and -1. So that's the domain. Now, next we have to do vertical asymptote. For the vertical asymptote, you also have to look at the domain, okay? The numbers that show up in your vertical asymptote column, let's say, should have shown up first in your domain part, okay? Now, in our domain, we had 2 problem points, 1 and -1. Of these problem points, either one or all will show up again as vertical asymptotes. So, here's the logic here. Whatever shows up as a vertical asymptote must have shown up in this purple box first. but not everything in the purple box will show up again as a vertical asymptote. Cool? Okay. So the vertical asymptote, again, it's the stuff in the denominator that doesn't cancel. So what did they tell us to do first here? Simplify the function. So here, let's simplify the function. It's x minus 1, x plus 1. Okay? Does anything from the denominator cancel? No. Please be careful. You cannot cancel x's because it's x minus 1 together in the denominator. So, because nothing cancels, you set x minus 1 equal to 0. You get x equals 1. You set x plus 1 equal to 0. You get x equals negative 1. Okay? So these are the vertical asymptotes. X equals 1, x equals negative 1.
And that's how you write vertical asymptote?
Yeah, hang on. Yes. So, now, okay, for vertical asymptotes, one thing that is extremely important is if you don't have the x equals part, you can't get full credit, just like for the tangents and cotangents and stuff, right? Now, you can also say x equals plus or minus 1. That works as well, but you must have the x equals. Okay, next, I need horizontal asymptote. So for the horizontal asymptote, we're going to compare degrees. It's easier to go back to the original function for this one, yeah.
Did you do that like x minus 1 equals 0 and that equal arrow thing?
No, you don't have to. I just did it because I was doing it horizontally. You can do it right under. Okay, so for the horizontal asymptote, you have to compare degrees. So if you go in the numerator, it's x to the what? 1. And then it's x to the 2. There is, numerator has lower degree. That means the horizontal asymptote is y equals 0. You don't have to you don't have to write that sentence form. You could just say y equals 0. There isn't much work to show for horizontal asymptote. You just have to, visually inspect. Okay? All right, we're cool with this? All right, let's do another one. Okay, domain. We're going to set 2x squared plus 1 equal to 0. Okay? We're going to set this equal to 0 and solve it for x. So minus 1 minus 1. 2x squared equals negative 1. Divide by 2. X squared equals negative 1/2. Take a square root, What's x equal to? What about the negative in the root? I root 1 over 2. So if we have an I, is that a real number? Not a real number. If you do this and you don't get a real number, that means there is no real number for which that denominator is 0. You cannot possibly find a number that will make the denominator 0, which means if the denominator is never 0, do we have an issue with this function? No issue. So the domain is all real numbers. Okay, let me write that down and then I'll. Yep. So, since answer is imaginary, domain is all real numbers. Okay? Yeah,
What we wrote as x equals plus minus I rooted 1/2, even though like isn't I negative 1 rooted?
Yeah, so that's why instead of the square root of -1, I wrote an I, and then I didn't write the negative anymore.
Oh, but it's still rooted.
It's still root,
Wouldn't
yes.
it cancel out and just be negative 1/2?
No, it would still be like I, because this is technically the square root of -1 times the square root of 1/2.
Oh, okay.
Okay. Okay, so the domain is all reals, yes.
So even though like I equals the square root of -1,
Uh-huh.
and this is the square root of -1/2,
Uh-huh.
even like I'm confused because -1 and -1/2 aren't the same thing. So how is
Because I was just saying to Yarden, this is like it's the square root of -1 times the square root of 1/2. The square root of -1 is I, the square root of 1/2 is 1/2, is the square root of 1/2. Okay, vertical asymptote. Because the domain is all reals, no vertical asymptote. Okay? If domain is all reals, no vertical asymptote. So you just write none on the answer space. None. Horizontal asymptote. You go here. 4x squared, 2x squared. Same degree. So I don't even need the x's. I could just say the coefficient of 4 divided by the coefficient of 2 is 2, so y equals 2. Okay? Okay. 3x cubed plus 3 over x to the 4. All right. So, domain. We're going to set x to the 4 equal to 0. Okay. So if it's x to the 4 equal to 0, there are no other numbers. We can take the 4th root of both sides. And so here we get x equal to 0.
so no matter what you square root 0?
Uh-huh. So the domain is all real numbers minus 0.
So the answer you want is all the numbers, not x equals something.
For domain, yeah. It's all real numbers minus something, or it's all reals, period. Yeah. Vertical asymptote. Again, we're going to set the denominator equal to 0. Same thing, we just said that x equals 0, so that's the vertical asymptote. Horizontal asymptote. 3x cubed over x to the 4. What do you think? There is 1. It's y equals 0. When you have more x's on the bottom, it's y equals 0.
Would you domain equals all the numbers minus 0, like 2 plus minus 0?
No, 0 is just 0. It's not a positive or a negative number. It's just 0. 0 is not negative, nor is it positive. It's not even, nor is it odd. It's just 0. It's like, it's like one of those singers or artists that are just known by their first name, like they just are. That's just 0. Okay? All right. So now we need to graph. Before you graph, you need to find a couple of things. So let's graph the following functions. Okay. Let's first find domain. You know what I'm going to do is, because I'm going to have to do this later, I'm just going to factor from now. So it's x squared it's x minus 2, x plus 2. So for the domain, what do I set equal to 0? The denominator.
Oh, you can do it like that.
Uh-huh. You could do it that way as well. So x equals 2, x equals negative 2. So my domain is all real numbers minus plus or minus 2.
Wait, are you setting it to 0 from the domain? Right?
Yeah. So now for the vertical asymptote, okay, do any of the terms in the denominator cancel? No. So you know what? If you showed me this nice, beautiful work here, I don't need to see more work here. You can just say, look, it's the same thing from above. X equals plus or minus 2. Okay? Right. So in the case where nothing in the denominator cancels, they're going to be the same. Okay? And I'm purposely giving you problems today with things in the denominator that don't cancel. I'm saving those for the next lesson. Now, before I forget, right, and move on to the next part, I mark my vertical asymptotes on the graph. So here and here. How many times is the graph allowed to cross these vertical asymptotes? Never, none, nothing, none. It's like a force field. You can't cross. Okay. Well, even that was taken down. These are never coming down. Okay. Number 3. No, Ronald Reagan has no power over vertical asymptotes. I'm sorry. Okay. No tearing down these asymptotes. Okay, next one. Number 3, let's look at horizontal asymptotes. For the horizontal asymptote, I go back to the original function before I factored, right? To be able to compare the degrees. X and x squared, y equals 0. Again, I don't really have to show much work because you know what? There isn't much work. It's just inspecting and comparing asymptotes. So y equals 0, y equals 0 here. If you're using a pencil, which you will be, and you know, like I've given the grid, if you do your asymptote a hairline above or below, so I can see it, that's good enough. My eyes have become very well trained to find vertical asymptotes. So if you don't have it, it points off. If you have it, I will see it. Okay? Okay. Now, we're going to graph this one. I'm going to show you how to graph it once because I want you to see, or this one, I want you to see how it all works. Okay? Now look. I'm also going to find zeros here. Okay. You know how you find zeros of a rational function? You set the numerator equal to 0. So in this case, x plus 1 equal to 0. X equals negative 1. So at negative 1, this has a 0. Okay? You see how it already is crossing the horizontal asymptote. So now, how many regions do the vertical asymptotes divide my graph into? 3. 3 regions, right? So now, on the left side, in the middle, it has to follow asymptotes on the top and the bottom. So there are 2 possibilities here. It can either look like this, or it can look like this, right? There are no other possibilities because it's got to cross this point for the 0, and then it's got to follow a vertical asymptote on top and a vertical asymptote on the bottom. So how do we know which of the 2 versions it's going to be? We plug in a point. My favorite point to plug in is x equals 0. When x equals 0, what's y? Let's plug it into the very first function. It's 0 plus 1 over 0 minus 4. Negative 1 over 4 here, right? So now do you see how that kind of like already narrowed down how this is going to look? Okay. It's got to look like this. So it's got to go up here. Okay. No, we're not done. Okay. Now, the thing with these asymptotes is they're like those video games, like those old like video games like Pac-Man and everything. What happens when the character in Pac-Man exits the screen on one side? It goes back in from the other side, right? Same thing with this. If the graph exits the screen from the bottom to the left of the asymptote, it re-enters in the top. And so now it comes down. Is it going to cross the x-axis at all? Are there any zeros there? No, but it's got to follow this asymptote, right? So it looks like this. Yep. Even though, because there's nothing else that it could possibly do. We know that if it exited here, it's got to re-enter there. And then it's got to follow this asymptote, so that's how it's got to look.
But you're not following anything.
Nope. I'm eyeballing.
You do it on the other side.
Yep. And now on the other side, if it exits the screen on top, it's got to re-enter on the bottom. But it has to follow the asymptote here. There is one way for it to look, and it's that. Right? Yeah. So if it exited, if the graph, so you know how we did the middle part, right? So now, if it went off the screen to the bottom and to the left of this asymptote, it has to re-enter on the right side from the top. And then on the edge here, it's got to follow this asymptote. So the only way for it to look is for it to curve down and follow that asymptote. Yeah, so yes. So if it's here, it's following this asymptote at x equals 2. It's to the left of the asymptote. It exits, and then it's got to come back on the other side, but it has to come back on the top. And here it's this asymptote. It exits, it's got to re-enter from the bottom.
How many points do you want to put?
Just these, and then the rest is just eyeballing.
So zero, just your zeros?
Yeah, and then 1 point for you to know which way. Yeah.
I don't understand like x equals to how do you get that in there?
I just picked a point. I picked x equals 0.
Okay.
Right? Because I wanted to know, okay, so I know that there is a 0 here, but from here, where does it go? Does it go up or does it go down? Right? So I just picked another point. You remember how back in algebra you used to do like a chart, x and y? That's what I'm doing. So when x is 0, what's y? Okay? Let's do another one and then...
How do you simplify?
What do you mean?
Like, could you simplify all the top?
The bottom one? Yeah, let's do this one and then I'll take more questions. So look here. Let's factor the top here. I get x minus 3. I'm sorry, x minus 4, x plus 3. Here, I factor out a 2. So I get x squared minus 4. But can I factor that further? I get x minus 4, x plus 3, 2, x minus 2, x plus 2. So now, for the domain, I'm going to set the denominator equal to 0. Yeah, it doesn't matter. I like to do the factored one. It's easier. I did leave out the 2 because it was going to divide out. So x equals 2, x equals negative 2. No, because I do divided by 2, that goes away. Yeah. So then the domain is all real numbers minus plus or minus 2. What are the vertical asymptotes? They're the same. X equals plus or minus 2. What's the horizontal asymptote? Because none of them canceled, right? None of the terms in the denominator canceled. So it's just the same, like it was in the numerator, like it was in the problem above. Horizontal asymptote, if they have the same degree, y equals 1 over 2, so that's right there. Okay, now, are there any zeros? I set the numerator equal to 0, and I do the factored one because it's already done for me. So x equals 4, x equals negative 3. Huh? Well, this is the numerator, so there is no. Now, negative 3. Now, here's what I'm going to ask you to do, and 4. I wanted to show you how it worked one time, but I am going to let you have your calculator with you to graph these. So once you show me this, all I want you to do is plug this into your calculator. I have my calculator back now. And then you can just graph it from there, right? No. Yeah. It's going to take a long time to upload, but our time is up. So you can use your homework. You can use your calculator for homework. That's the homework. The graphs on the homework must be done on what? Graphically. And the axes should be done using a what? Ruler. That's only if you want credit for them. If you don't care about credit, then you can do it on anything, with anything, however you want. Okay?